Hello everyone. I welcome you all to my presentation. Before I begin, I would like to thank Weyerhaeuser Forest Company, particularly Bob Winship, Kerry McKay, and Dave Swindlehurst for providing funding support for this project. I would also like to thank Forestry Corps, especially Ted Gruding and Andrew Johnson for their collaboration on this project. Today, my talk is about modeling intensive silviculture yield projection and sawlog profile for conifer plantations. Now, let me begin with intensive silviculture. Intensive silviculture is a precision silviculture where treatments are matched to sites' best potential and management objectives. It increases individual tree growth and shortens the harvest rotation. For example, with intensive silviculture, we can achieve an MAI of 6 to 8 cubic meter per hectare per year at best sites at a relatively shorter rotation of 50 to 60 year. Few other benefits of intensive silviculture. It improves the stand merchantability and thus makes stand eligible for earlier harvest. By shortening rotation, it also helps in mitigating risk of timber losses. Now, how do we implement intensive silviculture? We do it through plantations and proper density management on the best productive sites. Now, many areas in Alberta are experiencing mid-term timber supply shortages. In some cases, overall piece sizes are also in decline. Therefore, Alberta needs to adopt new forestry practices such as intensive silviculture. But Alberta is not there yet to adopt this practice. Not many scientific studies are also available at this moment. Therefore, the goal of this project is to bring more information to light on intensive silviculture forest management. Currently, I am working on developing enhanced forest management yield curves so that I can assess their impact on timber supply models. As a case study, Weyerhaeuser Pembina Forest Management Agreement Area, or FMA, is selected. In this FMA, pure conifer land base represents a good portion of their active land base. Active land base is about 51%, of which 25% is pure conifer. Therefore, there is a very good potential of intensive silviculture in this FMA. Now let's talk about our modeling approach. We used individual tree level model like MGM for growth and yield projections. MGM is validated in the context of Alberta. Individual tree data from managed PSPs at their performance age were processed through MGM. Different silviculture scenarios were simulated by varying the intensity and timing of thinning on a range of productive sites. However, in this presentation, I am only presenting a comparisons of results between two scenarios in the pure pine strata. One is the control or no thinning treatment, and the other one is the pre-commercial thinning followed by a commercial thinning scenario. Here, both treatments were modeled for established plantations. Pre-commercial thinning was applied at performance age, and commercial thinning was applied at the age of 35. So let's examine results now. We can see here volume responses in the first graph. In this graph, solid lines are representing thinning scenarios, and anything that are dashed are representing the control or no thinning scenario. Treatments were applied on a range of site conditions such as best, medium, and fair sites. Here, best sites are represented by red circles, medium sites are represented by blue triangles, and brown diamonds are representing fair sites. No treatments were applied on fair sites. So what we can see here is about 1.5 to 2.5 times yield increase from fair to medium to best sites. That means site productivity is the major driver in volume yield. Therefore, we need a better characterization of site productivity in the land base. However, we also can observe a slight reduction in final merchantable volume in intensive silviculture scenario. But let's examine the piece size responses in the second graph below. Here we can see a gain in piece sizes on the best and on the medium sites due to intensive silviculture. For best sites, I'm comparing the solid line, red solid line versus the red dash lines, and for medium sites, I'm comparing the blue solid line versus the blue dash lines. So right now, let's compare the stand merchantability between the two scenarios. The top graph is the stand structure of intensively managed scenario at best pine sites at age 50, and the bottom graph represents non-thin scenario at age 80 on similar site. We can clearly see a difference in stand structure between the two scenarios at different ages, age 50 and versus age 80. In intensively managed stands at age 50 are producing about 548 stems per hectare of commercial timber. That means trees that are greater than or equal to 20 centimeter dBH. Moreover, we also see that in these stands, the number of smaller trees that are less than 20 centimeter dBH are substantially less, which is approximately 187 stems per hectare. In comparison, unthinned stands at age 80 are producing about 520 stands per hectare, which is slightly lower than the intensively managed stands. However, these stands are also producing a significant number of smaller sized trees, like approximately 1,700 stands per hectare. And we all know that commercial timber value of these smaller trees are way less. Therefore, by examining these two graphs, we can say that intensively managed stands can meet the merchantability criteria sooner, can provide volume, and also can give us better value. So what is next? The long-term project of this, the long-term goal of this project is to develop an intensive management decision support tool for forest managers. However, in the short term, we need a better characterization or better prediction of site productivity over the landscape. We need to develop yield curves for all other strata, such as spruce and mixed-wood forest types. We need to examine diameter distribution across silvicultural treatments at different felling ages. Furthermore, most importantly, we need timber supply analysis combining both the volume and the value of the stand. And then finally, I want to conclude my presentation on two points. First, our initial results are encouraging for Alberta to adopt intensive silviculture, particularly for spruce and pine plantations. And why shouldn't we do it? when Alberta has the best soils in the Canadian Boreal. Besides, similar regions like Alberta have shown promising results with intensive silviculture. Second, while this study is ongoing in Weyerhaeuser FMA, I believe the results from this study can be equally applicable to other FMA holders across Alberta. Thank you very much for sharing your time with me.